The goal of this video is not to teach you Python, but how to get started using Thonny, the Python and microprogramming editor that we'll be using throughout the semester. I also need to warn you that this video is not a substitute for the explanatory text in your getting started with Thonny with Python 3 lab or homework assignment, because this video definitely doesn't cover many of the items that I've written up there. This is just supplementary material for those of you that prefer to see something before you actually try it. So although you may have used other editors for programming in Python or other languages before, we're guiding you towards Thonny for a couple of reasons. First, it's relatively small and fairly simple to use, given how many different things that it can do. Second, it also includes a pretty decent debugger that can be used with debugging Python programs on the PC. Having access to a debugger can be especially helpful when you're just starting out and learning Python. And third, it works with both Python on the PC and MicroPython on your Raspberry Pi Pico microcontroller board, which you'll be learning a lot more about in the next week or two. If you've taken an introductory Python course before, you may have used another IDE like IDLE or Moo. By the way, IDE stands for Integrated Development Environment, which suggests that it's more than just an editor, which is also true of Thonny. The standard Python IDE called IDLE doesn't work with microcontroller boards, so it's definitely not in the running for us to use as an IDE for this course. The Moo IDE, on the other hand, which we've used for the past couple of years in ME30, last time I tried it didn't work with the microcontroller board that we're using. It's also the case that Thonny seems to be better than Moo in pretty much every respect that I've found so far, so we're not encouraging anyone to use Moo this semester. If we confirm that Moo does in fact work with the hardware we're using this semester, we'll mention that in the course shell somewhere, although again it's not something that we'll really be supporting this semester for you. First, what you need to do is you need to download the installer for Thonny. So go to thonny.org, which you see right here on my screen. Let's see if I can find my cursor. I would really like to find my cursor. There we are. And so it's thonny.org. And depending on whether you're Windows or Mac, go to just press on the link, and in Windows it just pops up a downloader. Save the file. It's only 17 megabytes. Very quick to download. Clearly, if you're a Mac user, you click on Mac. I will point out that there is this, the current version is 3.3.13, and there is some information here on this page that might prove useful to you if you have any installation issues. There's not really much here. I haven't run into any problem running the installer, at least on Windows, for Thonny. So there shouldn't be any problems. So once you download Thonny, you'll get an exe file. I previously already downloaded one. There's not too many surprises here. It's a pretty standard Windows installation. So if you just double click on this, it gives you a an installer walkthrough. As far as I can remember, I've already got it installed, so I don't want to do it again. But there may be a question you'll be asked at one point whether you want to install the application for all users or just the current user. It's easier going forward if you just say I want to install it for the current user. However, there's no problem with doing it the other way if you want to. So I haven't run into any problems with Windows installation. However, Mac OS always seems to have an installation issue with a lot of other programs that we've used in the past. Generally, Mac OS wants to complain anytime you try to install an app that didn't come from the Apple App Store. If this doesn't end up being an issue for you, it's probably because you already took care of this problem, probably by using the first solution that we're going to show you, that I'm going to talk about here. The first solution is to change the global setting in your control panel that allows you to run foreign apps, namely non-Apple App Store apps, without harassing you about installing any other applications from outside the App Store in the future. The second way is there's some magic 1 or 2 key combination that you have to hold down when you try and run the installer to force Mac OS to actually run the installer rather than just cry about it not being from the App Store. I'll put a link or two to these articles in the show notes below in the YouTube video for how to solve this particular problem if that's an issue for you on your installation of Mac OS. So now that you've been able to install Thonny, hopefully, let's have a look at it. So I've I've already got mine hidden away on my start bar. So this is what Thonny looks like somewhere. There we go. Okay. So the first thing I'll warn you about, which isn't really a warning so much at this point, but eventually you may have your microcontroller board plugged into your USB port. And when that happens, when Thonny comes up, it'll recognize that it's there, and it'll ask you if you want to switch to the mode where it assumes that you're going to be programming Python on the microcontroller board. So that's probably the default if you have hardware plugged in. I don't right now, so it didn't ask me any questions about which version of Python I wanted to use when I started it. If for some reason you do have your board plugged in, you don't necessarily want to unplug it, but you want to use Python on the PC for programming because you're just doing some PC programming exercises, what you can do is there's this little label down here. This is actually a little choice box, and this says that you're in the mode running Python 3.x. 3.x is the kind of the standard Python for programming Python on the PC. The other mode that we'll be using is, I don't remember what it's called, if it's called MicroPython or if it's called Pico or if it's called MicroPython Pico. But with this you can choose a different version of Python to use. So you'll see that next in the next video that I'll be doing on how to use Thonny with your hardware board. So for the time being, just be aware that this is an actual choice box down here. So if you're doing Python programming on the PC, make sure this says Python 3. Whatever that current version is. So now we're just going to focus on writing some simple Python 3.x code locally on your PC, including learning how to use the debugger. So again, you want to get started by confirming that it says Python 3.x down in the bottom right-hand corner. So let's run a simple program. We're going to just create a new program here, and it's going to be pretty much the simplest little program that you can write in Python, and it's the standard hello world. Hello. So the first thing I'll point out to you is that once you've written code in this editor window, to actually run it, you press this kind of play button here up in the icon bar. And the first time you typically have to, you want to run something, if you haven't already saved it with a file name, you have to give it a file name before it'll actually run it. So I'm just going to call this trash.py because I don't really care. I'm going to throw it away as soon as we're done with it. So once I saved it, it went ahead and ran it since that was what I last told it to do. And as you'll see, it's actually printed out the output down here in this window. If I change it and save the new copy of the file and I hit play, there it runs it again with the changes that I've made. That's one of the really cool things about Python is that there's no compile and download kind of loop that you may be used to with other languages. With Python, you just change the program and just run it, and the Python interpreter runs it right away without any sort of compilation step. So that's a pretty simple program. I will also mention that if you're doing, well, let's just do it. If you ask for keyboard input, so let's just say variable equals input prompt, and save it. I did Control S there rather than hit the save icon up here, which is the kind of the Windows standard. You'll notice that the prompt shows up down here. So it's asking you for input, so I'll just type, hello, just to stop it from annoying me, and the program is run to completion. So that's it. Output and input end up going into the shell window, and running the program again from the start is just as easy as pressing on the run button. So now that we've pretty much run through the simplest example, let's go ahead and try and find a little more complicated example. I happen to already have one here. This is a children's game called FizzBuzz, and it's apparently was invented for children to be able to practice integer division. What kids do is they sit around in a circle, and everyone counts from 1 in their head silently up to whatever number the game ends at. And the challenge is that any number divisible by 3, instead of saying the number when you're asked, you have to say fizz. And if the number is divisible by 5, instead of saying the number, you say buzz. And if the number is divisible by both 3 and 5, For those of you who know advanced math, that's the same as saying a multiple of 15. Then you say FizzBuzz. So when you go around in a circle with a bunch of kids and you're playing this game, the last person to get it wrong is the winner. And if you get it wrong, you're eliminated. So you get yanked out of the circle and the crowd shrinks by 1. And the game continues until only one person's left. So what we're going to do is we're going to kind of mimic this game using a program. And the task is simply going to be to print out the numbers or FizzBuzz for the numbers from 1 to 100. So I've already got this loaded in my editor. If I hadn't had this loaded, I could find it with going to the open dialog box like every other program and finding the source and clicking on it. So that's what I would have done. So this version that I've written here is overly complicated for solving the particular task of mimicking the FizzBuzz game, but it's intentionally complicated so I can show you how to use the debugger. A real solution to this program can probably be written in about 4 or 5 lines, but that's not what we're doing here. We're elongating the program to show you some debugger features. So the first thing that I'll note is that you have the choice of when you're running a program to either run it, what's called free running, which you basically say just run the program, generate whatever output, ask for whatever input you need just like you're normally running, and run to completion. The other method is to run under control of the debugger, and this is the little debug icon. So you either run it free run or you run it with the debugger, under control of the debugger. So let's just go ahead and do that. So when we click on debug, what happens is it looks over your program just like as if you had free run it, and the first thing it does is just like, tell you what, let's go back. Let's just try and let it free run. This is the normal case. Everyone always tries to run their program hoping that it's going to work the first time. So you typically run it, and then if you find a problem, then you might go ahead and decide, okay, it's time for me to get in the debugger. So the first thing it's showing, and I intentionally did this, there's a syntax error in my program. And the nice thing about this is that it shows you in a couple of ways where the error might be. It shows you in the output window roughly with this little caret where it thinks the syntax error is. It also gives you a link that you can click on, and it actually takes you right to the file, right in the file. So line 22 is below where I'm looking. There we go. So it sends you off to that line. And there's also another assistant over here, which not only does it also have a similar link that gets you to the offending line, but it also gives you some English text as to what the problem is. And apparently in this case, it actually says, oh, well, do you think you forgot the colon? And the answer is actually yes. In this case, we did forget the colon. The colon we're missing is this one right here. So now if I was to save this program again and hit run, it would actually run. So I've already warned you that this may not be a perfect program. So let's go back and see what our output says. Let's see if it's doing what it's supposed to do, right? So it goes through the numbers, 1, 2, fizz. So fizz is a multiple of 3 is a multiple of 3. So it says fizz. 4 is the next number, neither a multiple of 3 nor 5. So it uses the number. 5 is a multiple of 5. So you say buzz instead of 5. Fizz, well, it's a multiple of 3. It's the second multiple of 3, so you say fizz. So this goes around. Now, the next interesting case, so you should always look at all the interesting cases. So the next case is 15 that we're interested in. That would be our first instance of FizzBuzz. And, oh, our program seems to have a bug. It is just saying fizz instead of FizzBuzz. So that's a problem. So while we're at it, let's just look and see if there's any other errors that we can find. Is 30 an issue? 30, yes, 30 is also an issue. Guess what? 45 is probably an issue, and it is. So we seem to have the same bug, and it's not obvious that we have any other bugs here. So hopefully that's the only program or the only problem we have with our program. So let's go ahead and try and fix that bug. So one of the things, especially when you're first starting out with Python, is the advantage of using a debugger is that if you're ever kind of unsure about where the program's running, you can run it under the debugger and you can actually have it step essentially one statement at a time. So the first stepping function we're going to introduce you to is called step over. Now step over does some nice things. It's kind of the fastest way to step through a program, and it basically executes one statement at a time. So what constitutes a statement can be a little confusing in Python. If you have a for loop like this, well, we'll get to it. I'll show it to you here momentarily. So if I want to execute the first line, notice that this variables window over here on the right is empty. That's going to change pretty quickly. So if I say step over, this means execute the next statement that is highlighted currently in yellow. So if I step over, it has executed the statement num max equals 100. Well, if you look over here in the variables window, it actually shows you, oh, there's a new variable that's been defined, and its current value is 100. So that's pretty nice. So the next step over is actually Python has to learn the definition of the function fizz, and that's its own statement. So we're going to step over that. Now, step over doesn't mean skip over. It means execute the statement that it's currently being focused on and go to the next statement and stop before you do anything, before you continue on. So I've stepped over, meaning I've executed the definition of the fizz function. I'm going to do the same thing for buzz here. So now we're basically in the real meat of the program. This is the for loop that goes between the numbers 1 and the maximum number plus 1, which once you learn how the range function works, you'll understand why those are the bounds. So typically when you count children, you don't count from 0, you count from 1. So that's why we're starting with 1 here. And why this is not num max, but num max plus 1, once you learn about the range function, you'll understand why that is. So if you'll notice, the next statement to be executed is the whole for loop. So just to show you what that looks like, let's go ahead and do it. So this is the confusion you may have about what's actually a statement. Why doesn't it just go into the for loop? Well, if you say step over, it's stepping over everything that's highlighted in yellow, which may or may not be what you wanted. So if you're half asleep and you said, darn it, I really wanted to step through that for loop rather than run through the whole thing, there's usually no harm. You just go back, run it again, and then you can do a couple of, I did run instead of debug. So debug, right, step over, step over. Once you've done this once, it's a lot easier. Okay, so this is the point at which I went too far. So now what I want to do is I want to do a step into. So what step into does is that every statement that kind of has a sub-expression, step into evaluates each one of those sub-expressions before it goes on to the next statement. So step into is actually very granular in this debugger. It's kind of interesting. You would think that maybe if I step into it's just going to do all of line 17 and go right to 18, but for some reason Thonny wants to execute every single little thing here. So if I do step into, for some reason it wants to execute the expression 1, then it wants to evaluate the expression num max plus 1. So it says, oh, well, num max is actually 100. So I'm going to show you that. I'm going to look at the 1, then I'm going to add the 2 together, and I'm going to show you that the result is 101. Whoopee. And so there's a lot of little clicks here for step into. So be warned that sometimes step into can be really tedious pretty quickly. I will show you very quickly how to get around that problem, how to do some kind of custom skip overs. So we're still, there we go. Okay, so the next statement that it wants to execute, it's telling me is what's in yellow, so it is the entirety of this if statement. So this is technically in Python a single statement. It is an if statement. It happens to have multiple pieces to it, but it's still a single statement. So let's say I wanted to actually see which of these paths it was taking. I would have to do a step into to take tiny steps rather than execute everything that's in the yellow block. So I'm going to do a step into, and if you look over here in the variables window, it's showing you that the current value of I, which is the iterator in this for loop, is currently number 1, which is what we'd expect. This is the first time we've gone through the for loop. So continue to step into. So it's, okay, fizz. So I is 1, shows you that it's 1. Now we're going to evaluate fizz. So now, if you notice, I did a step into. So step into, when the next sub-expression to be executed is a function, it walks you into the function, which you can then do a bunch of step over, step into, step backs, whatever. So let's continue to take these baby steps of step into just to show you what we're doing here. So it's going to evaluate this expression. N was the parameter passed in. N was 1 in this case, so it's going to do a 1 mod 3. 1 mod 3 is 1, and it's going to compare it to 0, and it's not going to be 0. So 1 is not equal to 0, so it will take the false path. So it's still doing the evaluation of the whole expression here. Okay, 1 equal to 0. It's not true, so it's going to take the else. There we go. So here's where it returns false. So if we were to do a step into, this is just a single statement here, so it's actually going to execute the return, and it's going to throw us back to the calling piece of code. So it's still evaluating the if. So because fizz of sub I, fizz with called with I, evaluated to false, you don't obviously do what's at line 19 where the print is. You continue on and look for a case of the if that actually evaluates to true. So we know from our outstanding mathematical abilities that 1 is neither a multiple of 3 or a multiple of 5 or a multiple of 15 for that matter. So this is not a particularly interesting case. So the problem we know we had was, well, let's just go ahead and do a step. Let's go ahead and do a step over to execute the rest of the code that was in that for loop. So now you can see it's actually prompting us here. It's showing us that the next value for I is going to be 2. So once we execute it, I think you have to do a step in. Well, no, you can do a step over because we want to evaluate that part in yellow. So it's safe to do a step over, right? So it sends us into the if. So 2, also not a very interesting case. So if I do a step over to execute that whole thing, it's going to print 2, and it's going to go up to the top of the loop for the 3rd time. We're going to do a step over to evaluate the expression as to whether we should bail out of the loop or not. So here, this is the next interesting case. So we know that we should be printing out fizz in this case. So let's go ahead and confirm that, and I'll show you what's kind of fun here about entering and leaving functions. So sticks in the 3, it's going to go to fizz. There we go. We're inside of fizz again because we did a step into. Now we happen to know that because 3 is being passed in, 3 mod 3 is 0. 0 equals 0, so it's going to return true. So one thing is that when you're in a function, I mean, a lot of functions are a lot longer than this. And let's say you get to a point in a function where you go, okay, yeah, I know what's going to happen in the rest of this function. I just want to go back to where I was called from. So there's this stepping function called step out. This says if I'm in a function, go ahead and do the rest of the function, step out, and then stop again. So it's actually thrown us back here into this into the caller. And if we continue to do let's just do a step here, and we took the if case here on line 18 because we are a multiple of 3, so we're fizzing, so we're going to print fizz. So if we step over it, it prints fizz. Sure enough, down here it goes up, and 4th time we're in the loop. So that's pretty cool. So that shows you that step over does whole statements where a statement is what's in yellow. Step into evaluates every tiny sub-expression that it can find. A very slow march through the code. And step out will send you from inside of a function back to the outer function when you're sick of looking at the function and you just want it to go ahead and run the rest of the code and return back to where you were called from and then stop again. The next thing that's kind of interesting here is, so we kind of already know this. So now I'll tell you what we're going to do. I'm going to show you how to use the next feature, which is called a breakpoint. So sometimes you want to run over and over again up to a particular point and then stop. So rather than step over dozens, if not hundreds of times to get to the point which we're interested in, what are we interested in? We're interested in the case where I is 15 because the program is not doing the right thing once I becomes 15. So one thing you can do is you can set what's called a breakpoint. So you double click on the line number and it shows you this little red dot. If you want to delete a breakpoint, you just double click on it again. So I'm going to reset the breakpoint, put it back there. Now what a breakpoint does is a breakpoint tells the debugger to stop whenever it hits that line. So what I'd like to do is, I don't really care about the case 4, 5, 6, 7. I don't want to do a whole bunch of step overs to get to that point. So what I can do is I can set a breakpoint someplace safe that if I resume, which is kind of the same thing as continue, it will continue execution until I get to the statement where the breakpoint exists. So if I look over here in my variables window, I can see that I'm on the 4th iteration of the loop, but I really want to get to 15. So rather than, like I said, rather than doing lots of step overs, I have a breakpoint here. So every time I hit line 18, it's going to stop. So I'm going to resume. Look over here, I is now 5. Resume. So now it's the 6th time through the loop. So this is a much faster way of me getting to 15. So I'm going to continue to click on this until I get to case 15. Okay, so 15, this is the bug that I want to track down here. So now I want to kind of, I mean, obviously I could look at this code and figure out what's wrong, but I'm just going to show you, I'm going to beat this to death. I'm going to show you how to kind of debug this in case you're kind of trying to debug a more difficult situation. So I want to go through this slowly, and I want to figure out now why is it not doing fizzbuzz. Okay, so the first thing it's doing is it's going to evaluate fizz, and it's going to say, okay, I is 15, so fizz is 15 of fizz. So continue to do little steps here. Okay, 15 gets stuck in there. That expression evaluates to what? It evaluates to 0, so it's going to return true. It's saying, oh, this is a fizz. Okay, I kind of believe that it's a fizz, right? Should also be a buzz. So now I'm going to step out, and I'm going to go back and see what's it doing. So if I was to take the next, okay, well, it said it satisfied the condition that it's a fizz number. So the result is, well, I print fizz. Well, it's clearly not what I want. What I clearly want is I want it to check if I'm a fizz and I'm a buzz. So then I should fizz and buzz. So the error in the code here is that what I want to do is I want to check first. I want to check both fizz and buzz. If I'm not both, then I can check fizz, then I can check buzz. And that's actually the right sequence of tests to do to make the code behave the right way. So I'll warn you, it's a little bit non-intuitive, but so what I know I want to do is I want to cut this code and I want to put it up here at line 18. However, if I select it and try and cut it with Control X or, you know, edit cut, whatever your favorite way to cut is, it's not allowing me to cut it out. Well, the problem is I actually have to stop the debugger. So I have to stop it to say, hey, I want to go back into editing mode. So now what I want to do is I want to hoist this sub-expression, this sub-statement, put it up here. So I have to start with an if. So that goes there. This goes here. And now I think I've actually written the code correctly to solve the problem that I wanted to solve. So let's do a save. You can click the save icon or do Control S. So just like every hopeful programmer, I think I've fixed the last bug. So I'm going to run the code and see if in fact I have fixed not only the bug I intended to, but see if it induced any other bugs in the change that I made. So let's go ahead and let's just let this free run. Okay, let's go back to where this program execution began. And let's start from 1 again, make sure we didn't make it worse. 1, 2, 3, fizz, 4, 5, buzz, 6 is a fizz. Okay, so we're looking pretty good here. Obviously the case we want to check here is 15. Hey, 15's fizz buzz, how nice. Everything else below that looks good. 18's a fizz, 20's a buzz, 21's a fizz, looks good. So let's make sure we've solved the 30 and the 45 cases. 30's fizz buzz, looks good. 45's a fizz buzz, looks pretty good. So we also were asked to go to 100. Let's make sure we go all the way to 100, didn't bail out early or go over 100. And 98, 99's a fizz buzz, and we finished. So that did in fact appear to be the last bug in the program. If you had found another bug, you would just go back and you'd run through the debugger again, step through all the places in the code that you weren't sure of, and eventually home in on where you found the error to be. So I think that's pretty much all the features of the debugger that I wanted to show you here. We've covered all the buttons that are in the Python 3 version of Thonny. Run, free run, debug run, step over, step into, step out, resume, and stop. So we've pretty much learned everything we're going to learn about how to use Thonny for Python 3 for getting started. So I hope this helps. You will now have some exercises to do in your homework or lab that helps you learn more about Thonny and gives you some practice doing so and actually solve some programming problems. So good luck.